again, you're getting 5 questions, all right? And certainly you're looking at these things over here, they should be somewhat familiar to you, but the bottom line, familiar or not, they may be difficult. For example, if you took the wrong approach to number 1, you could be there all day trying to figure that one out. Number 2, doesn't look that difficult to me, but you know what? Maybe it is. All right, number 3, at least I can't remember. Number 3, quadratic, looks pretty simple. Number 4, integrations. Integrations, in my opinion, are never easy, right? They always require something, unless they're obvious, but they always require some kind of thinking, like playing chess, for example. Number 5 also looks difficult to me, all right? Go to the key. What are you seeing? It's really the same thing over and over again. Video, problem, work. I also want to claim, I put a link over here. You can see someone else do the same exact problem, by the way. At least I believe that's the case. Can't really remember exactly where that leads to. Number 2, again, video, solution to it at the whiteboard. Also me working through the problem. I also on occasion provide what I call a visual aid to the problem. You may want to look at those as well, by the way. Number 3, as I thought, it was an easy problem. Again, video, not much work over here. But again, you could look at that and try to make sense out of it. Number 4, again, I want to point out over here, there's a link over here to somebody else doing the problem. And again, I really can't remember exactly. It's probably a YouTube video from somebody. But you may want to look at that, all right? Like you may want to look at mine, look at theirs, look at the typeset work, maybe come up with your own idea about the problem, all right? But I did go through it. Number 5, whoops, sorry about that. Number 5 is Newton's method. Again, if you're okay at coding things, boy, it's the same problem, isn't it? So this one is done by hand. Then all of a sudden they're saying use Newton's method with an initial guess here, and then they want you to find the exact answer from that, again, Newton's method, approximate method, by using this form up here. So you have to be able to do 4 to do 5, by the way. But what I do is I put the results down of Newton's method, and if you're curious about how to implement that, you may want to take a look at the Sage code at the end. But here's the deal. I also provide a link over here about exact solutions over here. And again, the exact solution and that approximate that is being returned by using Newton's method with that initial guess, by the way. Let me repeat this over here. You're to use this initial guess, all right? If you're using a different initial guess, you're going to narrow down in a different number, all right? Let me just go to the Sage code. I want to make sure that's available to you. You know what? In the Sage code, that's the partial fraction problem over here. They don't have the Sage. Let me just see if there's some link to me doing this in Sage. If not, I'm probably gonna have to post me doing the Sage code for that, all right? Because right now you're not seeing it, right? But I'll try to post if I can remember. If not, just ask me, by the way. I'll produce the Sage code for this. Thank you.